heading down. We have a delta of 14 right now.
Okay.
So, plenty of space.
Okay.
You just keep going down to the bottom. Just keep backing up towards me.
Okay. All right, engaging.
You can see me in your aft cam there.
Yep.
So, you just keep backing up.
Okay, I'm backing. Slowly coming down.
Ready to lower the bucket, blah, blah, blah.
Dick, we have arrived on bottom.
Yeah, I'm not ready
All
yet.
right, you ready to...
We're not good yet.
We are not ready to start.
All right.
Stand by.
All right, stand by, stand by.
They need to pull down on the cable, right?
I can't hear you.
They need to pull down on the cable, correct?
Pull down on the cable?
To be able to put the bucket up? Or?
No. There's like 20,000 pounds of force on that cable. Well, 5,000 pounds of force.
Bridge, this is ROV nav.
Okay, I'm still backing.
Yeah,
Go ahead, RV nav.
Just wanted to let you know that the vehicles are on the bottom,
Delta's
and I'd like
20,
to discuss a bailout plan.
Okay, I'm ready.
We'd like to set the bailout to east, please.
Okay, bailout has been set up here to east, and center of rotation?
Is set to the A-frame is what I'd like to verify.
Correct. I just switched it. We are now rotating about the A-frame, and bailout's east.
Excellent. Thank you very much, Bridge.
You're welcome.
Yeah, starting to get you in my camera here.
All right.
If you want to stay there.
Gotcha. Holding.
Turn the port. So you can start dialing in your Z-bias if you haven't already.
Okay.
All right, we're installing the rinser now.
They don't have the go-ahead.
Hey, Dick, do not set up the rinser yet. Stand by, please.
We already got it on. You can move the winch either direction when the rinser's on. It's okay. You can have video, bring a camera over to it if you want, just so you can keep an eye on it when you're going in and out. We're tying down the lines now, and then we're going to get the water adjusted the way we want.
We are here.
A little current pushing me back towards you.
Did you hear me? We're here. Yeah.
You deploy your swing arms here.
Copy.
Good morning, everyone. This is the Okeanos Explorer. Who do we have with us on the line?
Hey, Casey. It's Adrian Copeland with NOAA OER.
Morning, Adrian. Who else do we have?
This is Okeanos video engineer Roland Bryan making a general announcement to all those on the ship and the shore. This is a reminder that all audio associated with this dive will be recorded with our archive video, as well as being streamed ashore via the satellite and the internet. Keep that in mind as we proceed with the dive today, and enjoy the dive. Thank you.
All right. So who did we have just join us?
Hi, this is Tara Harmer-Luke from Stockton University.
Good morning.
Jason Chater, USGS.
Good morning, guys. Perfect timing. All right, Derek, what do you tell? Why don't you tell us?
Okay.
I was on, but I hung up instead of unmuting.
No worries. Derek, why don't you tell us what we have on video feed 3?
Okay, good morning, folks. Oh, am I on? Yeah. Good morning, everybody. This is Derek Sowers, NOAA OER, mapping lead. Today we're on dive 17, the final dive of the expedition, and we're diving on Currituck site, which is a big mass failure landslide feature. So we'll take a closer look at that. We did get some newer data overnight, and it really, really closely matched our existing data set.
All right.
So this is the new bathymetry being shown, just gathered last night.
And
if we turn on the older, it just matches really, really closely. So we got good maps of this site. This is 50-meter resolution grid.
Hauling in.
And we did manage to gather some new backscatter as well, so I can show that. The current dive site has a start of about 1,880 meters, and we'll have an ending depth, depending on where we do end the dive today.
The bearing's going to be 308.
Roughly around
that's the direction towards waypoint 2.
1,755
as
meters.
we head our way over there, I'm assuming that we'll line up with the contours, and that may change. But
so as you can see, we're starting on a flat area.
Okay.
Actually, let me turn the profile on for this.
CTD here for a second.
Copy.
Starting on the flats, proceeding for about 140 meters, and then going up this steep scarp, and then we'll be traversing it at some point.
I'm going to start.
That'll probably be governed by what we actually see as we're going up the steep. We'll do kind of a dogleg over to the south. And then we'll continue up the steep slope, which is about 30 degrees. And then hopefully getting to this other flat up on the top here.
Go ahead, they go off comms deck if you're all set and that's set up.
All right, thanks.
Incline.
D2 CTD profile.
Yeah, D2 CTD is ground ball. CTD's back on.
So if we look at the backscatter from last night, this was obtained by the ship moving along, sort of going on a north to south line, which should be a good orientation for the backscatter out here. We do see a high acoustic reflectivity, which is the white right at the beginning part of our dive, which is what we had sort of hoped for. So this is hard, apparently, and
like
maybe could be some exposed rock or something harder.
Yeah, I guess a hole.
So I think that should be interesting. And then we see that at the top of the dive as well. So depending on what we see, we might want to do this dogleg a little bit lower where it's a little bit brighter. And the ROV team has this backscatter loaded into HiPAC as well, so they can toggle it on and off to take a look at it.
So you can probably get to that if you want to go look.
Okay.
Any comments or questions?
Maybe.
It's a very cool feature.
It's over 25 meters away.
Would Jason want to tell us a little bit about what he is hoping to find on this dive?
I want to let science know that we're all set up and ready.
Rocks would be nice.
Watch leads pilot.
So hoping we actually see a whole.
I just want to let you know we're all set up on the bottom now, and we're ready to start
would be
the
ideal.
dive track.
The seismic data out here shows that there should be
Great, thank
a
you.
variety of those layers that poke out.
Copy.
So that would be a successful dive, just seeing that. But I think starting at the bottom, we hopefully will see a transition from sort of semi-pelagic bait over a different part of the landslide, over a sort of a wedge of material that's fallen off the slope, and then up onto the scarp itself, which will hopefully show this sort of deeper geologic history. So ultimately, we want to really find out why the landslide happened. We have a lot of ideas, and this probably won't answer it, but we'll add another piece of information that we can use. So just trying to tease some of the information out. Which we want to know if some of these layers are weaker than others.
Sure.
And if that has
kind of the bottom a little bit left right now.
So, that's the hope. I'm not opposed to seeing critters and stuff like that. But
I hope not. Otherwise, you might be disappointed.
Unless it's in the way of things.
Oh, great. Thanks, Jason. And the pilots are getting us underway, and we're looking at a holothurian here. Looks like echinoderm heaven so far.
I know.
Brittle stars, urchins, white urchins.
Feels good to be back in the deep sea. So we are just about to begin our dive. This is dive 17.
Video going in.
We are at a location well offshore at this point in 1,800, actually 1,880 meters of water depth. And we are at the broad flat surface that will lead to the base of a
going in. I'm going to set up
what we expect to be a steep wall. Take a look at this very interesting sea cucumber.
It's very flat.
It's very flat, and I think there was a second one over to the left of it.
Yeah, it's quite large too, 20 plus centimeters.
You can see why he belongs to Echinodermata, the spiny skin group of organisms. But not only does he have some spiny skin, he has a water vascular system. And related to the other critters you see.
Just to pass this on, Sean, we have a
brittle stars and sea urchin. And those are pencil urchins, it looks like.
Did you copy that, Bobby?
I did. Geo looks nice and stable, though, so it might not be that. Or it's just not affecting data.
Sure.
Yeah, looks like it's not affecting data. We're down at 1.4 megohms.
All right, Washies, we just did a quick pilot change. So I'm just sitting down and
1400
we'll get moving.
It's a dirt mound on the upper right.
Turbidity's all over the place. But
copy that. We're waiting for one more front row member to switch, and once we do that, we'll get on with introductions. So Nav, what's ship status?
Ship is currently stationary. Going to be moving about 325.
And maybe we should introduce ourselves.
Sure, while they're getting set up.
Copy that.
Have Derek go first since he might slip away.
Good morning, this is Derek Sowers, NOAA Office of Ocean Exploration and Research. I'm the mapping team lead for the cruise, and I've been responsible for mapping and sonar data collection, which is about half the ship time. We typically map overnight and map areas that have poor resolution data, understand what's in the water column and the topography of the seafloor, and we do have a sub-bottom profiler which actually gives us information about some of the shallow geology layering that you see that you can sense remotely. And that's of use to marine geologists trying to figure out the seafloor structure and hopefully insight on processes and history of how it was created and how it's changing over time. So we did get some new sub-bottom data last night over this large feature, of which we're exploring the small sort of front to it.
330.
And by my side is Cheryl Morrison. So I'm Cheryl Morrison from the U.S. Geological Survey, and I've been the biology lead on this expedition, Windows to the Deep 2018. And I've learned so much sitting in this seat in the last 3 weeks or so.
Good start, second watch.
All right, lining up at 3.
On my right.
3-0.
Good morning. This is Leslie Sauter from the College of Charleston, and I am the geology lead.
It's nice and flat, so.
I likewise have learned a tremendous amount of information, particularly of biology,
100 meters.
but also seen a lot of new geology that certainly never seen before, because no one's seen a lot of this before. But it's been a very educational, rewarding, and often very exciting experience. So hope we can share that excitement today with everyone watching on your Sunday morning.
What kind of stone do you think this is? Or is it rock at all?
I don't know. It's hard to tell with all the overgrowth and sediment.
Once again, we see a different brittle star than on the sea surface, the seafloor.
50 meters.
And
bearing
anemones.
330 degrees, decimal 2.
50 meters, bearing 330
Like
decimal 2.
a little sponge, or no, it's an anemone on the upper part. Yeah, and this little orange brittle star is one we've seen. It's very similar to, if it isn't the same one, we've seen throughout our dives attached to the harder substrate. You notice it seems to be avoiding the sediment surface below it. Probably isn't as adapted for moving across that surface, so it clings to the hard substrate, whatever it can find. Sometimes it's other organisms, and sometimes it's solidified material that has made its way here.
Move is in 50 meters.
Copy that. And watch leads. Front row is completely switched over, so we can now do introductions if it's still a good time.
It certainly is.
Great. Hi everyone, this is the front row. We are all from the Global Foundation for Ocean Exploration. We're in charge of maintaining and also operating the ROVs, and also responsible for all the video you see today. Sitting pilot right now is Sean Kennison, and to my left at navigator,
Bobby Moore.
Sitting as co-pilot is Fernando Aragon.
In the far right, Roland Bryan doing video.
And I'm Art Howard on clipping.
And we have thoroughly enjoyed working with this whole crowd here. Great ROV team and great video team. It's been really fun.
Yeah, and watch leads, just let me know if you want zooms on anything, and we're just going to make our way forward.
This is Tim Gallaudet. I'm the acting administrator. I think I'll be talk to you a little bit.
Hello, Admiral. Nice to hear from you. We can barely hear you. If you can speak a little louder into the microphone.
Sure. How do you hear me now?
That's better. It's clearer, certainly.
All right. I just wanted to thank you all for what you're doing. This is a real delight, and I've been following you every day. And we really, at the leadership at NOAA, are going to give our full support, continue to give our full support for this great program. So enjoy this last dive, I understand, of the expedition. Is that correct?
Yes, it is.
Yes, it is. And we have beautiful weather for this last dive.
Well, that's great to see. I will be following along.
Pilots were
and want much to contribute. So I'll just sort of sign off now from what I'm saying, but know that I'll be listening and watching with just great enjoyment. So thank you all very much.
Thank you, sir.
Thanks so much for joining us.
I can move pretty quick.
My pleasure. Have a great dive.
Thanks.
Copy that. Let's go for this one. We'll put me more center.
So for our viewers at home and on the internet, the gentleman that just called in, Admiral Tim Gallaudet, he is the top official in NOAA, and it's a great honor that he's following our activities and calling in. It's really a pleasure, and we have a very supportive and excited leadership team that's watching our adventures at sea here.
What do you think about this rock, Leslie?
I'm trying to contain myself so
I
as
know.
not to interrupt Derek. At last. So, I don't think, no, that's not a cannonball next to it. But, yeah, it's great to see some
Watch
hard
leaks.
rock.
Is this something you would want to sample?
I don't think we need to sample this, but I'm going to let the rock collections belong to the ideas and requests of Jason Chater, but I would suspect that we'd want to get a little closer to the wall than we are.
Understood. We are.
Yeah, I mean, I want to pick up every rock, but
I'm sorry, Jason.
there isn't that much space. Can you hear me?
Yes, now we can. But what did you say? I couldn't hear.
Okay. I would like to pick up every single rock that we come across.
Of course. I hear you.
These ones are surely displaced from somewhere. Right? They may even be drop stones.
Yeah.
So,
yeah, so we should wait, right?
I think so. I mean, even put some pictures of them are probably good enough.
Mm-hmm.
One that this urchin seems to enjoy.
Don't want to steal his.
It looks a little. Looks a little igneous or granitic. So, which could be a completely wrong.
It's pretty hard to tell, isn't it? It's interesting that it hasn't been colonized at all.
Which makes me feel it's pretty young, at least in terms of when it's
straight ahead. Dark.
Copy. Let me look left just in case there's another one.
And speaking of young, since this is a kind of more recent feature, we might expect a different type of biology on this wall that we're heading towards.
Super close to it, between your skids.
Young is as far as geologic time.
Geologic time. I wanted to make sure you qualified that.
Right.
It's very good right now.
Go ahead.
Pilot.
Yes,
we could expect maybe, since this is an impact of a failure event, that there will be low diversity and low abundance compared to outside of this landslide boundary. And so far we've seen very typical
start to come in video?
Soft sediment fauna. And this guy we haven't seen in many dives now, but we have seen.
We got out of the deeper waters.
And now I have to try to remember what its name was.
Just added 50 meters to the
But in the
end of this
meantime,
move.
while you're looking that up, it's a pancake urchin.
That's going to set us up closer, about 50 meters off the base.
It's filled with fluids, and
50
when it
meters off base of
is brought up to the surface, it flattens out, which is how it gets its name.
Turn to the west.
And you saw the little booties on its feet.
50 meters.
Help it to migrate across soft sediments.
Slight tilt up. How's that?
Good.
And it has those little baubles in the middle that may be similar to another species we've seen that are like little hypodermic needles that can eject a small needle into its prey. And like all of the echinoderms, it uses a water vascular system to pump fluids into tube feet that help it in mobilization, and in the case of urchins, help to move the spines that are adapted for walking.
Let's go full screen.
Copy.
And its cousin, the pencil urchin, over just behind it.
Not sure that is a pencil urchin.
Well, I mean pencil in that it has long spines. I didn't.
It might not be Citrus.
Yeah,
it might be.
Yeah, it may not be that
echinoid.
genus. Yeah, I was being too generic.
Video's clear.
All right, come wide, kill pipe and kill fog lights.
And the brittle stars. And we've seen a lot of brittle stars just hanging out on the sediment surface. Certainly in the shallow areas where our dives were almost completely sediments. We saw many of them, and in some cases they dominated the seafloor like they do here. We haven't seen quite this many urchins, though. They're very abundant here.
Probably want to look at the fish.
Yeah, we saw the other item, right?
Yep.
Copy.
Okay, centered on
It's another
330.
sea cucumber or holothurian in the foreground. And is this a rat tail, I assume? It's a different...
Yeah, that
we
looks
still
like a rat tail.
Call it a rat tail. It's a different species. Have we seen this species before?
I don't think so.
Remember seeing one this dark.
No.
And with this fin arrangement where the pectorals are high up on the dorsal side.
If we can get a view of its tail after this, that might help us out with the identification. Amanda Demopoulos from USGS says it might be a holosaur, and we have seen holosaurs during this expedition, but I don't remember one quite this dark, this black.
Old species.
Copy.
There's another fish to your port upper. Do you see it in my camera?
To port, copy.
I don't think we have any of our ichthyologists on the line this morning
very
yet.
Tight between the eyes.
Tight for the eyes, go for it.
In lieu of collections, we do as much as we can with our video, and it has served a great purpose, especially for the fishes. 'Cause the only ones we seem to catch are those that somehow take a ride on our ROV as we ascend. There are little surprises in the wet lab each night that the ROV team has plucked from the outside of the ROV.
And those are usually small fishes that are in the midwater generally, not benthic fishes.
Saw a cutthroat eel. Haven't seen them in a few days.
Synaphobranchus species. Yeah, it does look like a holosaur, though.
I'm going to do a quick zoom on Fish Dead Center video.
Hey, Mike Vecchione here.
Hi, Mike.
I heard you say there weren't any fish people on the line yet, so I just want to let you know Amanda's right. That is a halosaur.
Okay, great.
Not a rat tail. And I should be able to tell you the species, but I can't right off the top of my head. But it's definitely a halosaur.
Excellent. Thank you. And thanks, Amanda.
That's all I had to say.
All right. Well, don't be far.
And holosaurs are known from deeper waters greater than 1,000 meters, so it makes sense that we would see them here. We are at 1,880 meters.
Just let them swim off.
And you were talking about recent, which of course geologically when we say recent we mean in the range of thousands of years instead of millions of years. And Jason wrote in that they have dated the last major landslide occurred here at 14 to 16,000 years ago. And he's been watching the dives instead of working on revisions of that paper that will report those numbers. So thanks for the sneak peek at your future publication.
It sure is addicting watching these dives and
right next to the rock.
anticipating what we might see next. And I think I'm going to go into withdrawal when I get home in a couple days.
I know, and there's not even an ROV cruise following us to watch. I mean, there will be soon, but not immediately, so we'll have to
take
wait
our highlights with you to watch.
Yes, we will definitely take the highlights to watch.
And keep looking over the next few days on the website, because we're going to be getting more videos and highlights up on the website. Well, that's an interesting tube.
It is it looks like a
Just look down at the opening.
You know, a tube for paper towels.
Yeah.
It's not, but it's the dimensions of length to diameter look something like that. And there's some worms to the side of it. I think somebody had noted those earlier when we looked at the rock feature. Worm tubes.
There's something living in there.
You can see the end of one of the tentacles of whatever lives inside of it.
It's the size of one of the Cerianthid type of tubes, but I've never seen them laying down sideways. Or right against the sediment.
Let's look at the whole thing.
And we see on the rock a serpulid I haven't woken up yet. Serpulid worm tube.
Right side of that triangular rock.
Which are
Do you want lights off?
more often
Not
on
yet.
the bottom sides of rocks, that from what I've seen at least. Is not to say they can't be on the top side.
Oh, this is one of the little benthic holothurians. We collected some of those on dive 9, I believe that was. The rocky area. But this is quite a bit deeper than we were then, isn't it?
Yeah, yeah, definitely. Yeah, related to that large flat sea cucumber that we saw on the seabed. And we're likely to see more
90
of.
degrees on the rotator.
Copy that.
Video's clear, light's clear.
Great.
So these are definitely
Lasers
out of place
across
rocks.
the
We're
species.
far from
Lasers on.
the wall. Or we're approaching the wall, so
Lasers
hopefully we'll see
there.
some more that are at the base or the
catch
foot
up.
of the wall that we will ascend in today's dive. But we are seeing more and more rock debris.
Three, 0 lined up
You
and
can
push.
see increase in the number of the pebbles on the seabed.
And one thing that we noticed on a dive where we were traversing soft sediment like this and seeing these same brittle stars were that they were basically over dispersed. They don't seem to like to touch each other too much. They are very well scattered across the seafloor.
They need their own space.
And same with the urchins.
It's an interesting little, looks like that was a piece of indurated mud that might have rolling down and collapsed. I don't see a burrow associated with it, so it looks more like a consolidated
small fish that,
piece of sediment that came
urchin
from
up
somewhere
top.
else.
Copy.
And Jason says that lots of small mud clasts are scattered around. The debris from the landslide contains massive amounts of the rounded clay balls. So we'll
come in for fish video.
Did you find the name for this?
I haven't been able to find the name for
Yeah,
that.
I don't think I have it.
Let me just swivel around.
I've gone through a bunch of our dives and my notes from them anyway.
lead parasites off of it, or is he just using it for current blockage?
There's a whole lot of current down here, so I don't know.
That looks like a
Navigator,
cuskeel of some
pilot.
type.
Do we have an
doesn't it?
idea where the surface current is coming from, or is there any?
There's surface current or current down
I
here?
think that there was
the
a known
surface current.
association between these species.
At last report, it was low, about half a knot from roughly where the ship's pointing, so roughly from the west.
Okay.
Got a video. Let's,
but moving around.
Got to center up Sirius. Let's leave it.
ROV nav bridge.
Go ahead, Bridge.
Just wanted to let you know that move's complete and current update out of a 300 at 0.8. So off our starboard bow, and ship is still holding nicely.
Pilot, if we could just take a quick zoom on one of these rock fragments.
Yeah, copy that.
0.8, just off the starboard bow.
I was thinking more to the one to the left of the screen, just outside of the screen.
That I can do. The one down below or up front?
Now it's top center.
Top center, copy.
Yeah.
My rotator is at 90 degrees, pilot.
Copy. Alright, video, let's do a quick zoom on rock.
It looks like it's chipped away a little bit. But yeah, some of those fragments almost do look like granitic. But surprising to see it have crumbled, so very hard to identify a rock without holding it and also getting a fresh surface. Yeah. Let's see what Jason thinks about that.
Alright, video. Whenever you're ready. Time to push out.
Sorry, I was talking to myself on mute.
That's a bad habit to get into.
Well, I answered myself, which is even worse. Some of these more harder, for want of a better term, looking rocks are certainly look to be more igneous. They don't have a heavy iron manganese coating on them.
Mm-hmm.
Which, makes me think that they've been either covered up for a while, or they were dumped here, or come out of some deeper layer of
stopped 2 minutes ago.
The sediment. But what we're looking at now is more what I would expect.
Those are the
for us
first
to find,
wild pink
which is more of this
from series.
sort of debris material that's been shed off the scarp. So partially lithified, heavily bored, well exposed material that just kind of falls off from a very high slope comparatively to a lot of the seafloor. So we should be seeing more and more of this as we get closer. Maybe. Is that better?
Rats.
Okay.
So Scott France found something about this relationship that we just saw between the pancake urchin and the cuskeel. And there's a paper by John Moore and Peter Oster that describes this commensal relationship. The small cuskeel, approximately 6 to 9 centimeters, tentatively identified as Barythrides. Which is no Fiidae, and the pancake urchin, both the genera of Hygrosoma and Phorosoma.
Alright, lasers on it.
And I think it was the Phorosoma that we had seen previously. Thank you for that, Scott.
That video you can start to come in.
That's a beautiful anemone. We haven't seen that anemone yet.
Yeah, I wanted to spend a little more time with it. It's. I was trying to see if the white part was a separate set of tentacles, but it's just the base.
Has it got something?
Yeah, it looks like it found a little polychaete worm that it's eating. Either that or there's another one on the left.
Do you want more light video?
No, we're good. Thank you.
It's so bright and smooth, that whiteness.
Yeah,
and
it's
look
really
at
beautiful.
the base of it too.
Get some dust video.
You probably don't have time to rotate to the right 90 degrees, do you?
I could. The dust might cover it, but if you'd like.
Looks like we can see inside. You went 90 degrees left, not right.
Oh, they said right.
Yeah, that's going left.
I thought you meant turned right.
Oh, that's...
As in...
That's fine.
You turning right?
Right there.
Alright. Video while she's happy. We'll move on.
Okay. Slight tilt up.
These little mud piles, mud rock piles. Just imagine they tumbled down from upslope and then came to rest.
Been waiting to see if
began
got
to
any better
break apart as more organisms burrowed through them. But all the holes you see are likely from when they were in place.
Head west here.
Yep.
Or combination.
Copy that. Copa, you want to rotate?
Hopefully we'll see some more of these on the wall as we begin to climb it. We do another quick zoom, or maybe you're heading too much to the left here.
Yeah, we're going to go directly west. Watch
okay.
Reception. Directions to the slope.
You can get us some of those things if you want.
If you do want to stop at anything, though, Washer, it's
okay.
Just let me know.
Okay, I'm facing west.
Copy that. Pretty much centered. A little more. Alright, I'm looking west too. Sonar still looks good.
So Scott France found another bit, or probably reading that paper that he mentioned about the cusk eels and the urchins. And the paper said that cusk eels foraged around the periphery of the urchins and took refuge at the base among the long spines on the arboreal surface.
So we're going to go about
and
280.
they suggest that such associations provide juvenile cusk eels with shelter from predators or flow, or maybe even both, and access to prey from
30 meters.
far from other forms of refugia. Yeah, if you can imagine getting down close to all those spines, that would definitely be good protection.
RV nav bridge.
Ship move, please.
Okay,
I think we actually saw that where we had, yeah.
Yeah. 280 degrees.
Snuggling under the spines.
Okay,
Can we take a quick, you're probably doing it, but of the large
Good copy, thank you.
piece on the left. And
on the left side?
Yeah, yeah.
Copy.
And Jason writes that these displaced rock masses are really interesting for evaluating timing when they have corals and other sessile organisms on them. Either they stayed attached while tumbling down slope, possible but unlikely, or attached once it settled in its final resting place.
There's a tiny little snail on the right.
It does make you wonder how these particular brittle stars made it to this deep sea, flat sedimented area where they don't seem to like that substrate. So
yeah, it's a long way between these.
Yeah. So maybe they were able to ride it out by being in the burrows.
Any spots in particular, watch rates, on this rock?
No, I think we're going to keep going if that works for you. Yeah, we just want to.
All right, video, come on.
We're seeing some sponges. I guess those are more encrusting type of sponges compared to some that we see.
Mm-hmm.
Watch leads now.
Tilt up.
Our tracking isn't real precise at the moment, but I would estimate we've gone our first 100 meters.
And we've gone about 100 meters since we hit the seafloor.
And we're expecting about another 40 meters before we begin the climb.
And there's the holosaur again in the distance. And one of the mysteries of all of these species and where they are and why they're there is the small planktonic form of the juveniles or larvae, and we don't really have much of an understanding of that part of the life history of most of these species. Definitely true for the corals. If they spend a lot of time in the water column, they might be able to disperse pretty widely.
Yep.
They might be able to swim. They might be buoyant and go to a different portion of the water column. They might wind up in the upper water column where they'd be transported by the Gulf Stream. Or they might stay benthic and stay kind of closer to their parents. Oh, here's our first coral. The Desmophyllum is the little cup coral on the lower right. And look at those tiny baby urchins up there. Wow.
And at the base there's another of those attached holothurians.
Oh yeah, this is a great rock.
All rocks
you
are great.
have room for this one on top of D2? Maybe strap it down.
Put them in the backpack.
Somewhere.
And to the right of the rock are some chips of it, it looks like, and so you can see a relatively fresh surface instead of this blackened surface that is probably from precipitates in the water.
Geological question for you. These rocks we're seeing today have sort of a reddish tint to them, but still granity looking. What in stones create that reddish tone?
Well, in granites, the pinker the granite, and Jason, definitely chime in. I'm just remembering my geology from igneous rocks, but the red is a function of the type of plagioclase, or a type of feldspar mineral, and some of them have different colors, so the pinker minerals are more of the potassium-rich feldspars.
Yeah, I think most of the red color we see on the rocks certainly in this environment comes more from the sort of the beginnings of the accumulation of that iron manganese coating.
Forward? Yeah.
Or an alteration rather than
going off screen just
primary
to see video.
Sort of mineralogic coloration, but you're right. If it was a cleaner surface, the pinky colors would be the potassium feldspars.
Yeah, it's really hard to tell what is a fresh surface. Even if it's broken away from a rock, it could have been sitting exposed to oxygen-rich waters for a very long time and causing that iron to oxidize as well. Wow, look at all of these organisms on the one rock.
Wow. It looks like a very collectible rock if you wanted lots of specimens.
Ooh, that would be interesting with all the... We'd keep Stephanie busy for the rest of the cruise with that rock.
Well, if we call it a biosample, yeah. I mean, that's up to the biologists if you want to do it, because this would go into a biobox.
Are lasers on?
Yeah,
You'd lose all your biological life if we put it in a rock box.
I think I would prefer to hold out for some corals.
I think you should.
But it's so hard to decide.
Great.
It's very gratifying to see Cheryl get excited about rocks. Sorry, Jason.
Yeah, one thing I'm seeing in some of this newer debris are these sort of almost tube-like sections.
Set up close on it.
And we've seen those before, and I'm hoping we actually see. You'll see it with a hole in the middle will be kind of round. I'm hoping we see that in the scarp itself. We've wanted to sample some of those for a long time to figure out what makes them.
Looks like that move's done.
Whether it's a biological process or a fluid type process or something else. So hopefully we get to see those. We think they're probably biological, but we're not sure. So fingers crossed.
Yeah, and unfortunately, if it is biologically originated, we rarely see the organism that made it.
Copy that. Should be approaching slopes in pretty high pack, right?
According to high pack, we're on the slope.
Huh.
I don't see anything in sonars.
Yeah, nothing.
So I'm going to give you another 30 meters.
Yeah, sounds great to me.
More coral on the right.
Bridge, ROV nav.
Yep.
Go ahead, RV nav.
Can I request the same move, please?
Sure, 30 meters.
And I wonder if this is an anthomastus here, or pseudo-anthomastus.
It must be clinging to something. We don't usually just see them in sediments.
Right.
Come in.
Yeah.
Kill lasers, clip that.
Move initiated.
We haven't seen that in a while. Definitely prefers deeper waters.
And I think that Tina said that the ones with larger polyps are pseudo-anthomastus, so that might be what we're looking at here.
Let's look at the one that's curved over at the bottom.
The sad one?
Yep.
Oh, yeah. One of the tentacles is kind of deflated on the bottom there.
I didn't know what that was.
Full specimen. What do you make of that structure? What do you make of that structure in the background?
Go for zoom.
So is that mud formation?
I don't know.
It's actually one of those things I was talking about. Has this sort of open aperture, and this one is kind of filled with sediment. But when we see them in the walls, they're really deep
Video's clear.
open aperture surrounded by this ring of sort of often discolored sediment or rock. So we've seen some really massive ones, perhaps as big as a meter across.
Really? I guess I didn't realize earlier what you were talking about, so maybe we could, there's some more here littered on the left side, lower left pilot.
Yeah, copy that.
We could zoom into some of these circular brown features.
Yeah, the abundance of them suggests that it is biological.
Our videos start to come in.
But,
huh. Yeah, they look like the tops of tubes.
Yeah, on the chat room, folks have been hypothesizing about possibly a Cereanthid tube anemone tube or a crab burrow. I was wondering if it could even be a polychaete burrow with all the polychaetes we've seen.
Look how rounded that one is.
And then we have the, I guess those are brittle star arms there underneath one of these.
Okay, video's clear.
and they persist for an extremely long time.
You happy with that, Washington?
Sort of Miocene type age rocks. With open apertures, they don't collapse. The material around them must be pretty strong.
The muds plus the organism's mucus really binds those particles.
Right.
In geologic descriptions, what are they called? What do you refer to them as?
Holes.
Just holes. Well, I like the non-complex version.
We've seen some that are, heavily mineralized, are in sort of concentric rings. So they'd be thought to be fluid pipes, but we really haven't been able to look too much into the ones we found out here in the Atlantic. I only first saw them back in 2013, which was prior to D2 having a sampling capability. So we'd be hoping to see them again.
Yes.
The more we look at the video, the more we actually tend to see them hiding in some of the exposed rocks.
Copy that.
They're prevalent.
It's kind of all by himself.
And is this a different octocoral?
That brittle star is standing up. I thought I saw one earlier.
Oh, yeah.
Go for brittle star first.
Looks like he's doing a back bend.
Yeah, it's like a yoga pose.
Yoga pose, yeah.
Crazy. I saw a couple others earlier and couldn't tell if my eyes were playing tricks or not. Those are definitely shadows. It's a brittle star version of plank.
Move complete.
Copy, move complete.
I was thinking down dog, but maybe plank is more appropriate.
Plank.
80 degrees on the rotator pilot.
Copy that.
More of an active pose.
Let's go for coral before we run that
straight up.
Copy that.
Ooh, look at that.
I wonder if that is...
Hold on the central neophyroid.
And here's our third species of brittle star that looks like the kind that we typically see with these. Are these octocorals? Looks like an octocoral.
Yeah, and the snake-like brittle starfish.
And again, it's amazing how this one organism found its way to the type of substrate it prefers.
or at least can tolerate.
Out of time.
One little hard substrate there. And Scott said that's probably a Paramaricia species and an Astrosema brittle starfish. You can tell it's a very different brittle star than all the rest of them surrounding it.